here we are reviewing our properties of circles. And in this particular case, we are given inscribed angles. Okay, so using your notes on inscribed angles, hopefully you remember that the arc is 2 times the angle. Okay, so what that means is that arc xz is going to be 2 times 40. So that happens to be 80. Now, you can also see we have this inscribed angle, angle Z. And it doesn't give us the angle, but it does. Oh no, it doesn't go through the. It doesn't go through the. It doesn't go through the center. I thought it went through. If it goes through the center of the circle, it's a diameter. In this particular case, it does not. So the question is, what is the measure of this arc here, xy? Okay, well, remember, the other thing you need to remember about circles is that circles have 360 degrees. It's double a triangle. So if I subtract 120, and subtract 80, that will give me the remaining piece of the circle, because everything has to add to 360. And 14 minus 8 is 6, which is not an answer. So since 60 isn't an answer, clearly I made a mistake somewhere. And my mistake is in my subtraction. 3 minus 1 isn't 1, it's 2. So my apologies. But 14 from 8 is 6, leaving me. So my remaining part of my arc is 160. So this is 160. And because angle Z inscribes that arc of 160, angle Z is half of 160, so that makes this angle Z 80. I know I didn't ask you that, but it's a good review. Okay. Same thing here, but in this particular case, QS is a diameter because it goes through the center of the circle. If the measure of angle Q is 54 degrees, what is the measure of angle S? Okay. So again, we're dealing with inscribed angles. So first, we can find the measure of this arc if we needed to, but we don't in this particular case because it's not asking for the measure of the arc, but actually the measure of angle S. Let me erase that so it's a little easier to see. But what we do have is we do have this angle here, which is a diameter, which also has to be a straight line, which is also a straight angle. So the question is how many degrees are a straight angle? Happens to be 180. And if QRS is 180 degrees, the measure of angle P is going to be half of that measurement. Remember the arc, because if this angle here is 180, central angle means the arc's 180. And the angle is half the arc because, or we can say the arc is twice the angle. So to reverse twice, we're going to cut it in half. So that means angle P is half of 180, which happens to be 90. So angle P is actually 90 degrees. So because we have a triangle, triangles only have 180 degrees. Subtract 90, which is 90, and then subtract 54, and I can get angle S. And that happens to be 36 degrees. Okay. Here we have, oh, this one doesn't have a diagram in it. So I'm going to give you a diagram. Okay. So here's our circle. It says there is an inscribed right triangle. Okay. And let's say our diameter is 10. This is the center. That's my diameter. Use your reference sheet and find the circumference. The formula for circumference is 2 pi r, or it also lists the circumference as pi times d, because that is the relationship between the radius and the diameter. The radius is half the diameter, or, no, I said that backwards, sorry. Yeah, the radius is half the diameter, or we can say 2 times the radius gives us the diameter. So, if my diameter is 10, then my circumference would be 10 pi. Now, if you were to cut the 10 in half to get the radius, to use the other formula, half of 10 is 5, but I'm going to multiply it by 2 anyway. So we get the same answer, 10 pi. This is what it's called when there's pi in your answer. What that means is that you do not need to multiply by 3.14. The pi in the answer removes the requirement of multiplying the diameter or 2 times the radius by 3.14. This is what's called leaving your answer in terms of pi. And our last property for circles, which I may or may not have included in your notes, is that anytime you have a quadrilateral that's inside a circle, your opposite angles are going to be supplementary. So what that means is that angle T plus angle V is going to equal 180 degrees. So that's 5x minus 1 plus 3x plus 5 equals 180. Combine like terms and solve for x. So if I add my x's, you should have gotten 8x. Negative 1 plus 5 gives me a positive 4. Subtract 4 from both sides. I get 8x is equal to 176. Divide both sides by 8, and we get x equals to 22. But that's not what the question asked. The question asked for the measure of angle V. So now that I know what x is, I can plug it in to my expression of angle V, which is 3x plus 5. 3 times 22 is 66. And when I add 5, I do get 71. These last two is asking for the area of the sector and the area of, the arc length. Okay. So what you need to remember here is that the area of the sector is only a portion of the total area. So what we're going to do is calculate the total area, and then we're going to multiply it, the total area times the portion it asks for. Now the portion is based on the angle. Central angle is the same measurement as the measurement of the arc. So the portion I'm looking for is the 120 degrees out of 360. Area is pi r squared. In this case, we are given the area. It happens to be 6. So pi times 6 squared, and that's the same as 6 times 6, or 36 pi. And when I multiply 36 times 3.14, I get 113.04. Okay, so that's my total area. And that's the area of the whole circle. So to get the area of just the shaded region, I'm going to take 113.04 and multiply it by 120 over 360. Now, remember, when we multiply by fractions, put the whole number over on and multiply straight across. So we're going to multiply 113.04 times 120 and then divide by 360. So 113.04 times 120 divided by 360 gives me 37.68. And if you notice, it says closest, so when we round our answer, we get D. We're going to use the same steps to find the arc length. This time we're going to use circumference. Okay, so find the total so the formula for circumference again is 2 pi r So we have a circumference of 2 times 3.14 times 6. Multiply all those together, they're going to give us the total circumference. Then multiply that times 120 divided by 360, which gives us the portion, and we will find our length of that arc in inches. Okay, last one I want you to do on your own. Your diagram is here. Find the area of the sector and the arc length in inches.